Okay, so let's practice finding a few of those reference angles. So first up is 217 degrees. So remember, we always start from the initial side here. Stick with blue for my reference angle. So here we go. Here's my initial side, 217 past 180, somewhere down here in quadrant 3. So this is 217. My reference angle is this blue guy, right? Back to the nearest axis. What am I going to do? I went past the 180. So my reference angle is going to be the 217 minus the 180. So I'm left with 37 degrees. Negative 48. Negative 48, always start here on the initial side. Negative, so we're going down 48 degrees. So this angle here, is negative 48 degrees. Reference angle is the angle back to the nearest x-axis, so that's going to be 48 degrees. Now we haven't done any graphing with radian measures, but no different. So if we look at this was 90 degrees, this was 180 degrees, this was 270 degrees, and this was 360 degrees. If we put those in terms of radians, 360 degrees all the way around was 2 pi. So halfway around the 180 is pi. The 90 then is half of the pi, which would be pi over 2. And the 270 would be 3/4 of that, or 3 pi over 2. So I want to graph 2/3 pi. So I think about 2/3. This is a half pi, this is a full pi, and this is either a 0 pi or 2 pi if we've made it all the way around the circle. 2/3 in relationship to 1/2, it's greater than a half, but it's less than 1. So 2 pi over 3 is going to be somewhere here. Remember, we start on the initial side. This is a positive, so we're going 2 pi over 3. Our reference angle then is this piece here going back to the nearest x-axis. How much is that? Well, all the way to there is pi. So what's the blue part, the reference angle part? It would be pi minus 2 pi over 3. Pi is really 3 pi over 3, so we're left with a pi over 3. And then we've got 2/5 pi. So again, this was pi over 2. This was pi. Think of this as a half. Think of this as 1. We're looking at graphing 2/5. So again, we start on the initial side here. This is positive, so we're going up 2/5. 2/5 is less than a half. So 2/5 pi is maybe there somewhere. Well, the reference angle is going back to the nearest x-axis. So that angle then will be the 2 pi over 5. How about our trig functions in each quadrant? If you think about the ordered pairs in each quadrant, in quadrant 1, our ordered pairs are positive and positive. In quadrant 2, Roman numerals for quadrants, this is a negative and a positive. Quadrant 3 down here, this is a negative and a negative. And in quadrant 4, we are positive and negative. This up and out of the way a little bit more. Okay, so let's think about the trig functions in each quadrant. Let's think about sine. Sine is y over r. Remember, r is always positive. So sine then is the y value, which is positive, over an r, which is always positive, so sine is positive. Cosine is the x value, x over r. R is always positive, so we'll have a positive over a positive, which is positive. And then tangent is y over x, so that is positive over positive for a grand total of positive. The reciprocals of these functions will be the same signs, S-I-G and S. How about quadrant 2? So sine in quadrant 2 is a positive y over positive r for a positive. Cosine in quadrant 2 is x over r. X is negative over positive will give us a negative. And tangent is y over x, positive over a negative, which is a negative. Quadrant 3, y over r, negative over a positive is a negative. Cosine x over r, which is a negative over a positive, which is a negative. And tangent y over x, negative over negative, which is a positive. And then in quadrant 4, sine is y, which is negative over the positive, which is negative. Cosine is the x, positive over positive. And tangent is y over x, negative over a positive, which is negative. So those are the signs of the six trig functions. We wrote down 3, but then the reciprocal functions will be the same as the actual functions. So here's our 2 problems where we're kind of pulling all this stuff together. Suppose theta is an angle in standard position whose terminal side is in the given quadrant. For each function, find the exact values of the remaining 5 trig functions. So here we have sine of theta is equal to 2/5, okay? And it tells us that we are in quadrant 2. So let's draw our theta in quadrant 2. So if we create a little triangle here, we can think of it that way, but we also know that sine is y over r. So we will have x squared plus y squared equals r squared. We don't know x, but we know that y is 2 squared equals r is 5. So that's x squared plus 4 equals 25. So x squared equals 21. Now, here's where the difference is. Before we would just say, well, x is equal to the square root of 21. But really, it's positive or negative square root of 21. We are in quadrant 2. X in quadrant 2 is, drum roll, negative. X in quadrant 2 is negative. So we really want the negative square root of 21. Again, this is different than our triangles. Our triangles, everything was positive. Now that we're working on the coordinate plane, we can have values that are negative. So sine was given to us 2/5. Cosecant, super easy, 5/2. Cosine now is the x, which is the negative square root of 21, over the r, which was 5. Secant then is the reciprocal, so 5 over negative square root of 21. Sorry, I had to squeeze this in here because I didn't want it to go on another page. So then we get negative 5 square root of 21 over 21. Remember, any negatives always get written in the numerator. Tangent is y over x. The y is equal to 2. The x is equal to the negative square root of 21. Rationalize. And we get negative 2 square root of 21 over 21. Sorry, squeezing that in there. I guess I can make it a little bigger. And then cotangent is reciprocal. I'm going to flip that one before I rationalized so that I don't have to rationalize again, because we all know how I feel about that. Okay? Again, we have to worry about the sign now, S-I-G-N. All right, tangent. Tangent of theta is equal to negative 3/4. We are in quadrant 4. So if I draw my angle here in quadrant 4, so here's my theta going around like that. My tangent is negative 3/4. So tangent is y over x. So that's a 3, that's a 4. Who gets the negative? Because I just said we always write the negative in the numerator. That doesn't mean the numerator was the negative piece. If we are in quadrant 4, the x is positive and the y is negative. Therefore, it will be a negative 3 for the y, and the x will be a positive 4. X squared plus y squared equals r squared. So we'll have 4 squared plus negative 3 squared equals r squared. 16 plus 9 equals r squared. r equals 20, I'm sorry, r squared equals 25, so r equals 5. Remember, r is always positive, so we don't have to worry about the sign on r, because it's a radius of the circle, it's a length, okay? So now we have x equals 4, and we have y equals -3. Find the 6. So sine is y over r. Loving that there's no square roots, so I don't have to rationalize. Therefore, cosecant is -5/3. Cosine is x over r. X is 4, r is 5. Secant, flip it over. And tangent, we already had that to start, so therefore cotangent is just the reciprocal. So that's kind of pulling it together with all the quadrants. Reference angles, we'll pull those in a little bit more in another section. Okay? Thanks, guys, and have a good night.